Welcome to Unit 4, Lesson 1, Properties of Exponents. Let's use integer exponents. Here are some of the basic exponent laws we are going to use. So let me put my highlighter on. When you multiply the same base, add the exponents. When you raise a base to a power, multiply the exponents. When you divide the same base, subtract the exponents. A negative exponent means flip the fraction down, because to make any whole number rational, put it over 1. What a negative exponent will do is flip the fraction upside down. Then the exponent becomes negative once it goes across the fraction line. Now, conversely, you can have a negative in the denominator, which will equal b over 1 to the n power. And if the negative is next to the letter or variable, it only applies to the letter or variable or number. But in the first case, the whole thing was in parentheses, the whole thing gets treated. Any number except 0, I meant to have a highlighter on, sorry. Any number to the 0 power except 0 is equal to 1. When you multiply different bases, the exponent stays the same. Anytime we see an letter or number outside of parentheses, that thing has to get distributed to both things. This law works backwards and forwards, and we're going to see examples of that. Okay, our warm-up today is which three go together. You could say A, B, and D go together because they're in exponential form. When you have a base and an exponent, it's called exponential form. When you have something expanded, this is called expanded form. And any number is called standard form. So these are the different forms that numbers can exist in, and you will hear that. So you can say B, C, and D because they're all correct. A is not correct. 2 times 2 is 4 times 2 more equals 8. So A is incorrect. There's all kinds of reasons you can make your argument and stick with it. Okay, now for this exercise, you're going to have to explain what law you use. So right off the bat, we have the same base multiplied, so we add the exponents. 3 plus 5 equals 8, so A equals 8. For the next one, B plus 7. We got the same base, and we know that B plus 7 equals 11. But what plus 7 equals 11? We subtract 7 from both sides, and B will equal 4. Okay. For number 3, we had the same base divided, so we subtract the exponents. So C equals 1. We have 8 minus D is equal to 2. We could subtract 8 from both sides. And negative D is equal to negative 6. Divide by negative 1. And D is equal to positive 6. All right, same base is multiplied. So that gives you M plus M plus M is equal to 21. 3M is equal to 21. See, here's the difference between exponents and coefficient. The number out front is called a coefficient. When you add or subtract, the number out front changes. When you multiply, the exponent changes. So we divide by 3. and m equals 7. All right, next one. Now this is raising power to a power. You have it in parentheses. So n times 4 equals 20. We know we have to divide by 4 on both sides, and n equals 5. Different bases. Different bases get the same power. So this is 2 times 3. We factor out the exponent. 2 times 3 is 6, and s equals 4. So s equals 4. And for the last one, we got the same exponent everywhere. So that's 5 times t equals 50. We divide by 5 on both sides, and t equals 10. All right? Okay, as we read the descriptions, they want us to write 2, the power of 2, so 2 in exponential form. Then we're going to evaluate it. So we know when we're dividing, we subtract. So 5 minus 2 is 3, so this is 2 cubed. 2 times 2 is 4, times 2 is 8. 5 minus 3 is 2, so this is 2 squared, which becomes 4. 5 minus 4 is 1, so 2 to the 1 equals 2. Anything to the first power is that thing. 5 minus 5 is 0. Anything to the 0 power that's not 0 is 1. 5 minus 6 is -1. And this is 1 over 2. And we're going to leave our answers as fractions. 5 minus 7 is -2. So this is 1 over 2 squared, which equals 1 over 4. A negative exponent flips the fraction upside down. And if you don't understand that 2 over 1 is equal to 2, think about it, and you'll see that this works. Okay, anything to the 0 power is 1, except for 0. What is the value of 3 to the -1? We put any whole number over 1 and make a fraction out of it, and this becomes 1 over 3. And then 7 to the -3 is 1 over 7 cubed. 7 times 7 is 49. 49 times 7 is 343. Okay, so now let's match our expressions. So 2 to the -4 is 1 over 2 to the 4th. Now I'm going to leave these in exponential form. Now, people get tripped up with this one. A negative exponent does not mean the answer is negative. It means the fraction gets flipped upside down. The fraction gets flipped upside down. When you see something written like this in the third case, this is -1 times 2 to the 4th. According to the rules of PEMDAS, you do your exponent first, then you deal with your negative. So if you rewrite it as -1 times 2 to the 4th, you will see that this is what the calculator will give you. It will give you 2 to the 4th, and then it will multiply by -1. All right, the fourth one is -1 over 2/4. So we're going to have to evaluate these. So let's do that. And evaluate means get down to a single number. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is 1/16. The second one is 1/16. This is -16. This is -1 over 16. 4 squared is +16. 4 to the -2 is 1 over 4 squared, which is 1/16. -4 squared is -16. -4 to the -2 is 1 over 4 squared, which is -1/16. That's because the negative is out front. The negative exponent does not mean the answer is negative. 2 to the 7 times 2 to the -3. 7 minus 3 is 4, so this is 2 to the 4th, which is 16. 7 minus -3 is 7 plus 3, which is 10. That's 2 to the 10th. 2 to the 10th is 1,024. And what I did, I hit 2, I hit the caret button. Anything bigger than x squared, I hit the caret button. I hit 10, you get 1024. -7 plus 3 is -4. That's 1 over 2 to the 4th, which is 1 over 16. Negative 7 plus 3 is, again, negative 4, 2 to the negative 4. Oh, so let me show you what I did. Negative 7 minus a negative 3. If you put your second term in parentheses, you will not get confused. This is 7 minus a negative 3. Two negatives with no number in between them tells you to add, which is 1 over 2 to the 4th, which is 1 over 16, and negative 4 squared. This means negative 4 times negative 4, which is positive 16. And now let's come back and highlight which ones are like. So we got 1/16, 1/16, positive 1/16, positive 1/16, and positive 1/16 again. Okay, so now for the next one. Negative 16. Is there anything like negative 16? We'll leave negative 16 alone for now. Negative 1/16. We have with this one and this one. Nope. Okay, let's look at our next one. It's positive 16. Positive 16 is here. Positive 16 is here. Positive 16 is here. Oh, I do have another negative 16. I forgot I wrote them up top.